So the first one is point-to-point, and there you have different application fields. And what we do now is we have here a bunch of literature in the end where we say where we found something. And what does it mean end-to-end, right? So it's a substitute for traditional point-to-point, better performance in wireless, 4G, voice over LTE, small cell, backhaul, satellites, Wi-Fi, content delivery networks, Ethernet, packet core. Wherever you have this kind of point-to-point, you go on two endpoints and tunnel through, transparent. Now, is this something where network coding will shine? Of course, you can recover from losses, but any code could do that. But what you see here are some improvement metrics. And there's something called coded TCP, which is end-to-end, because transport is always end-to-end. Even in between, you have many IP routers. It's an end-to-end from between the end systems. And when you look there, sometimes you find some implementation, like implementation in one that has a 10x performance. Then there's another coded TCP implementation that has throughput improvements of 5x, right? Where 3% losses are in the commercial public Wi-Fi, different publication. And we can go through it. There's another one, coded TCP eliminates video buffer overruns interruption over a 25 megabit link, even with 20% packet losses. Another, and RNC leads 4 to 6 times more goodput improvement for WiMAX. So different implementation, different architectures or technologies will have different numbers. But we are talking here always about 2x, 10x, right? Not percent. You know that engineering speak is if you have 10% improvement, that will change the system. This is dramatic. But there's not the one thing like in video compression, you say, by the factor of 20, we can compress video, right? That's not here. It really depends on the technology you're using, on the scenario. But there are a lot of evidence that there's big stuff in it. And then we talk about coded TCP, what it is really, we need something of the RLNC, which is the sliding window, the on-the-fly coding, in order to get something out of the end-to-end. Because if you just think about an end-to-end and you want to overcome the errors, then a block code, a Reed-Solomon would do the same. So where is that what Morten asked for, where it shines? It has to do with the latency, right? So sliding window is latency.